going on, guys? Welcome back. Today we are doing query results in the SQL Injection Fundamentals. So we're going on part 2 now of the SQL Injection Fundamentals, and we're going to actually kind of get a little bit more in depth with how we use SQL, and then we're going to actually do our first SQL injection. So pretty exciting stuff. We're going to get all the way to probably jump our intro to SQL injections, and then we'll take a break, come back part 3 to do the rest, because those are a little bit more complex and I want more time to explain them to you. So before we get started, hit that like button, hit the sub button. It helps out a ton. It's the only way I can grow, so I really appreciate it. All right, so first things first, in this section we're going to learn how to control the results of an output, which is true. This is important because some databases have millions and millions of entries, so you need to be able to control the actual output, right? So what we're going to do is here they're showing how to order them or sort them, right? So you can sort the results of any query by order by. So you can see select everything from logins. So they're going to get every login, and they're going to order it by password. So you notice now the password is in alphabetical order. So now the password column is in alphabetical order, but you notice the IDs are out of order, 2, 3, 1, 4, not 1, 2, 3, 4, right? Because it changes based on the password column. So that's one way to do it. And you can see by default the sorting is done in ascending order, meaning alphabetically A to Z. You can change it from descending from Z to A, right? So that's one thing to make sure you know. And you can see to change that, all they did was order by password, descending, and the command. It's also possible to sort by multiple columns to have a secondary sort. So you can see select everything from logins, order by password. So again, we're by password, but there's 3 people with the same password. So if 3 people have the same password, we want to set a secondary, which in this case is ID. So now it will actually put them in ascending order based on the secondary because they have the same value for the passwords. So what that means is if they have the same value here, it's going to revert to this ID and put them in order that way. All right. So now limit results. This is something we might do if, for instance, we know in this case the logins, the first user is going to be an admin. We would probably say give us just the couple first results because we want the admin, right? So we'd say select everything from logins, and then we limit it to 2. So we only want 2 entries, 1, 2, right? That's something that you're going to probably use a decent amount if you are looking at thousands or millions of results. Okay, let's see what else. So now we have, if we want to limit results with an offset, we could possibly, or specify the offset. So what we can do is we could say, select everything from logins, limit 1, which is the offset, and give us 2 results. So what that means is we have 2 results and the offset is 1. So we started at the second entry because we offset it by 1, right? So that means starting from 0, it starts and includes the second record and returns 2 values. So it said, okay, get rid of that first entry. Let's go to the next one, and we just want the 2. So you can do offsets if you're looking for a specific user. For instance, let's say we're looking for user 100, right? We could say limit, and we could do our offset could be 99, something like that, and then say only give me 1 entry, and I would get user 100, right? So there's different ways to do it, but the offset's good to know. You may not use it as often as you think, but it is something you might want to use if you're trying to find a specific person. Now, if you know the ID number, for instance, user 100, I could just say select everything, or select everything from logins where ID equals 100, right? We could do that too, which is what we're getting into next. So this is a little, let you refine it a little bit more and actually kind of dive deeper into specifically asking for certain things, right? This one up here, these select everything from logins with limits, that's going to be more if you're looking for something but you don't know exactly where it is. You just have a general idea, right? So for instance, it's typical that the admin is going to be user ID 1 or whatever, so you may check there first, and you don't want a list of a million results because it's going to take forever and clutter up your workspace. So you just say, hey, let's just look at a couple real quick and see if admin's in there. But if you actually know exactly where something is, you can do something like this. Select everything from the table where condition. So what's the condition here? Here they're saying select everything from logins. That's the table. Logins is the table ID. Where ID, that's this column here, is greater than 1. So you notice 1's not here. but 234 is. So anything greater than 1, spit it out to us. So if we're looking for 100 here, we could say we're ID anything greater than 99, right? That's one example. So now we say select from logins, select everything from logins. This asterisk is just a wildcard saying select everything. So select everything from logins where username equals admin. Now you notice here we only get one result because you notice we actually filtered by username. So we said where the username equals admin. Okay, that's great. But what if we don't? What if we want admin, administrator, all that type of stuff? Well, now we can say the like clause. Another useful SQL clause is the like clause. So we can say select everything from logins where username like admin, and then this % is a wildcard, meaning admin and anything after. That's what it means. Admin and then anything after. And you can see admin, administrator both pop up in the same table where before we only got admin. So that's one way we can do it. The other way is right here, this underscore symbol. Select everything from logins where the username is like and boom, boom, boom. That means right here, match with this exact number of characters, 3 characters, right? All usernames with exactly 3 characters in them, because it can be any letter, but the difference is with the %, it can be 100 letters after, where this we're saying specifically we want 3 letters. That's it. So if we were looking for administrator, for instance, we could do admin, and then we could do, if you look, 1, 2, 3, 4, 5, 6, 7, 8 underscores, and get administrator as well, if we were trying to filter out some of the fluff we were going to get from the wildcard. Okay, so now we're actually in. Let's go ahead and exit so that we can completely not clear. That way we can completely start from scratch, and we can see, okay, we refresh this target. What is the last name of the employees whose first name starts with bar and who was hired on 1990-0101? Okay, so we got to figure out who's the first one. So first, let's connect to the actual database, right? Let me make sure. Did I just change the IP? I think I did. Yep, I did. Okay, so this is the new IP. Okay, so what we got to change it to what was the port? 46930. So 46930, and then the IP was 94.237. So 94.237, 62.195. Okay, so this command is pretty simple. MySQL, username is root, the host is the IP, and then the port is this, and then this TAC-P lowercase here, that's just saying we want to enter the password. We don't want to put a password in there. And that's just good practice. You never want to put a password in plain text. Okay, and you can see we have the Maria database, whatever you want to call it. And first thing I'm going to do is say show databases. So now we have employees, information, MySQL, blah, blah. Well, we want to go into employees. So we're going to say use employees. Okay, now we're in the employees table. And now we're looking for the name of the employee whose first name starts with bar. Well, first I need to know what tables they have in here. So show tables. Okay, so here we have departments, blah, blah. Well, we're probably going to use the employees table. So now what we're going to say is show or select everything. If I can find the wildcard here, there we go. Select everything from, and the table we're going to use is employees, and we're going to say where, and we have to use the first name starts with bar, where, and if you go up here and look again, where, and then in this case we don't know the username, but it's saying first name, so we're going to say where first underscore name, and we're going to say, just like they did up here, like, right? Because we know it needs to be like this, like bar, and then a %, because we want the anything after it, right? So we know it needs to be like bar, And then we can say, okay, and we want to say, what was it, hire date or something like that. We'll try hire date and see what it says. Hire date, and the hire date was 01/01/1990, right? 1990 01/01. Now this may not be correct, and I'll show you why. Okay, yep, so it wasn't correct, and I'll show you why. What did I do? Okay, so first things first is I'm going to say select everything from employees because I want to see what the actual names are called. So you can see there's all kinds of information here. That's fine. But I need to know the actual names. What are they called? Right? Hire date may not be correct. So we want to see what are they actually called. So it is hire date and it is first name. Okay, so we got it right. That's perfect. So it's hire date and first name. Perfect. Now we go back down and we look at our syntax because it said our syntax was incorrect. Okay. So now we say, and hire date, we did not put an equals. That's why it syntax is incorrect. We want hire date equals that. All right, and there we go. You can see we have Barton Mitchum. He was the only one with the name, first name Barr, and then hired on 1990/01/01. So right there, we say, what is the last name? Mitchum. We go ahead and we go on to the next one. Okay, now we have SQL operators. So these are what you're going to be using a lot to kind of validate certain things. You use operators a lot when you're doing SQL injection, so make sure you understand them. Okay, so the AND operator, we just used that one, right? We just said where the name is like bar, and we use the and we wanted, you had to be hired in 1990/01/01. So we just used the AND operator, right? So the result of the AND operation is true if and only if condition 1 and 2 are true. So what that means is if you say 1 equals 1 and 2 equals 4, it's going to return back false. That's not true because they both have to be accurate. It's important that you understand the difference because and if both of your conditions or multiple conditions are not true, you're not going to get a result, right? If you have or, then only one has to be true. So you can see here's an example, 1 equals 1 and test equals test. You get back 1, which means true. That is true. Now, if you do select 1 equals 1 and test equals ABC, test does not equal ABC. So therefore, yes, 1 equals 1 does, but both have to be true. So that ends up being false. So now the OR operator, this one is different because you can say 1 equals 1 or test equals ABC, and you notice it comes back true. Why does it come back true? Because 1 does equal 1, and this is either or. It's not and, it's either or, right? So then select 1 equals 2 or test equals ABC. Neither are true, therefore it is false. All right, now the queries above demonstrate how the OR operator works, which we just did. Now the NOT operator, this is something that you'll use a lot as well, especially if you're needing everything in the database except for something, right? So select not 1 equals 1. Well, this is pretty self-explanatory. If it's not 1 equals 1, then it's not true, right? So the not operator simply toggles a Boolean value. True is converted to false, vice versa. So it's the opposite of true, right? So not 1 equals 1 is false. Not 1 equals 2 is true. Pretty self-explanatory. It just flips, right? So now we say, okay, the symbol operator. So you can use and or not just with symbols. This is something you're going to see a lot, especially when you're doing, if you do SQL injection in like the URLs and things like that, rather than doing them. So if you're actually putting them up here, it'll save you a lot. It also helps with the spacing and stuff like that when you're doing URL encoding, all that stuff. So the and or not operators can also be represented. So and is just 2 and signs, or is just 2 straight pipes, and then not is just exclamation point. And you're going to see us using not with the exclamation point, right? So not equal to, etc. So you can see here, select 1 equals 1 and test equals ABC. So this is the exact same thing they ran before, except for it evaluates the exact same way. It's not true. These are important, like I said, to know because you will use these as you go. So select 1 equals 1 and then the pipes. So or test equals ABC. That should be true because 1 does equal 1. And that's what we get right here, right? So it's important to know the difference because let's say you're doing a SQL injection and somebody sanitizes your output, meaning they do not allow you to run the OR command, but they forget to actually sanitize these pipes. You can use the OR command then, you just can't use the words OR. So think of it that way. So now you have select and then 1 is not equal to 1, which makes 0, right? 1 is not equal to 1, according to this, right? Because we're telling it it's not. So now let us look at how these operators can be used in queries. So select everything from logins. So again, from the table logins where username is not John. So you notice nobody here's name is John, even though John is in the table, because we said we want everything except for what is named John. Now the next query selects the users who have their ID greater than 1, and this is something you're going to see in the example we use here in a second. So we say select everything from logins, where username is not equal to John, which we did, and you notice we had 3 results here, and then the ID is greater than 1. So this admin is now removed because the ID was 1. So that's why we would use something like that, because we're trying to get very specific here. Now, multiple operator precedence. SQL supports various other operations such as addition, division, as well as bitwise operation. Thus, a query could have multiple expressions and multiple operations. Okay, and what they're saying is they take precedence. And so what they mean is division, multiplication, and modulus, those take precedence over these other commands, meaning these will run first, then addition, subtraction, then comparison, then not, then and, then or. So it's important that you know that, because if you try to say or first, it's actually going to run and first. So what they're saying is here, select everything from logins where username is not equal to Tom and ID is greater than 3 minus 2. Well, look, addition and subtraction happens first. So 3 minus 2 actually happens before the comparison, meaning this will be equated to 1 before it compares it, before it says this. Now that's important because if I was to read this, right, and I thought the order of operations was just simply ID is greater than 3, then that wouldn't be the same thing as ID is greater than 1. So you need to make sure you know what order of operations it's running. So from the parameters, we know that subtraction comes first, so 3 minus 2. So that's why it equates to 1 here, right? So now we have ID is greater than 1 rather than ID is greater than 3 minus 2. It will automatically do that first. So make sure you know those orders of operations if you're doing complex queries. So now we have select everything from logins where username is not Tom and ID is 1. And you can see we get the same results as we did over here, but with a lot more complex of a query. Okay, so now we're still in the same database, employees database, right? And it says in the titles table, what is the number of records? So we know the name of the table, right? And it's what is the number of records where employees number is greater than 10,000, excuse me, where the employee number is greater than 10,000. Or, well, first thing I'm going to do is the same thing I did before, which is select everything from titles. And the reason I'm doing that is because I need to see what actually I need to see what actually the names of them are. So you'll see, okay, we got employee number is employee number in EMP underscore no, right? And then the rest are pretty self-explanatory. So that's important that we know that, because if you just used employee number based on the name they gave you, it wouldn't work. So in the titles table, what is the number of records where the employee number is greater than 1,000 or 10,000? Well, what we can do is, spoiler alert, they gave you the number right here. But if we wanted to actually do the command the way that you should, it's driving me nuts that when I click in there, it automatically goes back up. So we can say select everything from titles where the number of records, where the employee number, where emp number is greater than 10,000, okay, or title does not equal or does not contain engineer. So we'll say does not equal engineer. Let's see. And we'll say, or title does not equal, we'll say engineer, and we'll see what it says. And look at that, we get 654. Now, that's exactly how many is in the table. Why would we get the exact same result? Because you're saying to yourself, well, engineer is, there's a bunch of them with engineer, but look what it says, or their title does not contain engineer, not and, meaning that it's gonna equate this one first, and there's all of them are over 10,000 because it starts at 10,001. So therefore that is our answer, 654. So it's kind of a trick question, just heads up. Okay, we're gonna mark complete and move on. Okay, now we're getting into the intro to SQL injections. This is gonna be our last module we're gonna do, and then we're going to dive into these next time and then finish out with exploitation, mitigation, and close out. So now we have a general idea of how SQL works, and we can actually go ahead and start learning about the SQL injections. So this is the PHP code example they're going to give us, right? So what this is they have a connection, and that's new, MySQL, localhost, root, password, users. Okay, cool. And they say select everything. This is the query they're going to run. Select everything from logins. Okay. And then the result is connection, query, and then you notice they're calling on the query here. Okay, so they're giving that query. So when you actually put in input, it will change that query. That's what we're trying to inject SQL commands into. Okay, so then the query will be stored right here in result, and we can print it out to the page or use it in another way. So we could say, yeah, print it out and show us what it looks like. Okay, echo, that's fine. We could do that, but that's typically not what you're going to do. You're typically going to use it for something besides just showing on screen. Web applications also usually use user input when retrieving data. For example, when a user uses the search function to search for other users, etc., their search is passed on. So we could say search input, we're sending a post, find user, right? It's saying select everything from logins where username is like, and then put your search input here, right? Okay, well, cool. Then it's going to run that query. Well, we need to break out of that. We need to run whatever command we want, not just put in the input that we tell it. So if we use user input with a SQL query, and if not securely coded, it may cause a variety of issues like SQL injection. Yep. Okay, sanitization. We talked about this before. It refers to the removal of any special characters in order to break any injection attempts. So we could see here, and SQL injection occurs when user input is input in the SQL query. Thank you. Okay, so this is what it would look like, the actual query itself that's happening on the back end of the database. So when you go into a website and you're searching for something, this is the query that it might look like. It'll say select everything from logins, if that's the table, where username is like search input, right? Well, what if the search input is where it's putting in the information that we inserted into the search command in this case, right? Well, what if we change this and broke out, right? So if we put admin, it becomes %admin, right? So that's where it's putting it in. In this case, if we write any SQL code, it would just be considered as a search term. For example, if we put input show databases, it would just be show databases, %show databases, right? It would just be in quotes. That wouldn't make any sense. The application will search for usernames similar to show databases. That's not what we want. We want to run show databases, right? So what we can do, and here I think this is a terrible example of what they did, but we can add a single quote which will end the user input field. So think about this command this way, right? Here's the search input. You see how it's already quoted for us? They will put those quotes in. The actual PHP code will do that. Well, what if we put a quote right here, right? Instead, what if we put a quote right here? That will close that out, and then that means we can start running commands. So if we actually said, okay, put a quote in there, which ends the user input field, then we say show databases, then we end the command, right? It will actually do that for us. For example, if we search for one, but see how they put a quote in there? They quoted it so that this would be quote one quote. So that way the rest of it is actual commands being ran. Then they ended the command and said new command, drop table users. So right here, I think it's a terrible example because don't ever do this, especially on a pen test. You could get yourself in a lot of trouble if you're dropping tables. You never do that because it's literally like if they don't have backups, you just deleted all their users, right? So don't ever do that. Use something else like show database, show tables, something system info, whatever. Do something besides this. Don't drop tables. So I don't think that's a very good example that they did. Don't do that. But you can see, so the final select query looks like this. Select everything from logins where username is like, and then here's where our normal search terms enter, right? And then we say, and we added drop table users, right? Perfect. Well, keep in mind that this search input is still there. So we sometimes have to comment that out, and they didn't show that here, but maybe we're getting into it a little bit later. And you'll see this will drop the table users, which we don't want to do, right? Now, syntax errors. The previous example of SQL injection would return an error. Okay. And near line 1, near blah, blah, quote, dash, quote, 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 right? This is because the last trailing character where we have a single extra quote right here, right? That is not closed, which causes SQL syntax error. So this is actually called quote balancing. And what it is we have an extra quote in here, and they're adding 2 quotes. So there's going to be quote, quote, quote. We need to fix it. We need to balance those quotes so that there's the correct amount of quotes to close it out. So this, because the last trailing character we have a single extra quote. So we have this extra quote in here. We need to get rid of it. So in this case, we had one trailing character as our input from the search query, which was from before. However, the user input usually goes in the middle of the SQL query, and the rest of the original SQL query comes after. To have a successful injection, we must ensure the newly modified SQL query is still valid, because if it's not a valid query, it's still not going to work. So we need to actually have balance on that. So one answer is by using comments. So it says they will discuss this later in a section, but basically what that is at the end here, instead of this extra quote, instead of having a quote there, you would comment the rest of it out. So the rest of it is not a valid command. It's not going to run. Sometimes that won't work. And so you may have to just put the correct amount of quotes in the correct places to balance the query out. The easy way to do this is to test this out on your own system. So build a quick SQL database, get the tables to be whatever you want them to be, right? And run the query that you think the website's running and see what's valid, and then try it. Now, there's types of SQL injections, right? There's SQL injections in band, blind, and out of band. And then we're going to get into union-based, error-based, Boolean, blah, 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 blah. Okay? So in the simple cases, the output of both the intended and new query may be printed directly on the front end. And that's where we saw here, we got an actual, right here, error, near line 1, blah, 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 syntax error, right? That is in band. And that's because it's error-based, meaning we get an error, we know that we're running SQL commands because we're getting an error directly on it, right? Most websites are not going to show you the errors anymore. That's kind of an older thing. They usually kind of sanitize those so you don't see them, but it's still possible. With union-based in-band attacks, right, which means you're getting direct feedback, you're putting a query in and you're getting a result. We may have to specify the exact location, which we can read, so the query will direct the output to be printed here. So union-based means you're putting 2 commands together. You're unionizing them. You're putting the command that they want, and then you're union and putting another command that also gives you the same results. So, for instance, if the command that we run, the query that we run, they give us 4 columns. For the union, we have to request 4 columns. It has to match, and then they will put them all in one table for us to view. And I'm sure they're going to dive more into that. Okay, Error-based SQL injection, it's used when we can get the PHP or SQL errors in the front end, meaning we can actually just see the errors. We can request it, make a mistake on purpose, and it tells us, hey, you have an error in your SQL. That's what it is. That's what in-band error-based is. In more complicated cases, this is known as blind SQL injection, meaning you run a query and you have no idea if it worked because you don't get a response. Did it work? Are you actually running commands on their SQL server? You don't know. So how do you do that? Well, you can do Boolean-based and time-based. Boolean-based is just you make a conditional statement that is true, right? And if the output equals true, then it worked, right? If it's false, so let's say username is, let's say it says valid user or invalid user, right? Like we showed before where it said successful login or failed login. That's true or false, right? Success or fail. So if we run a query, we may not get any output, but we know success or fail. That's Boolean based. It's true or it's false. There's no in between. Now, the time based is something like this, a sleep function. If we have no output at all, we're not getting any response from it, we don't know if it's working, right? We can say something like sleep. Hey, run the query and sleep for 10 seconds. If that page takes 10 seconds to respond, that query was ran, right? It's not normal for a website to take 10 seconds to respond. So that's another blind technique. All right, so, and finally, in some cases, we may not have direct access. So what we can do, and this is called out of band, because we have to output the response to a remote location, meaning, what if we don't have access, we aren't getting responses, we don't know if we're doing anything? We can use the SQL command to do something like look up a DNS record. And if we have a DNS server and we say, hey, look up this DNS record, right? It can reach out to that server. If it touches our server, we know it is working. Even though we're not getting a response on the website at all, it's out of band. It's reaching out to our remote system and showing that it is working. We do have response. So that's out of band. It is a way to basically do a blind injection where you don't know if it's working, but you have to validate before you start just running commands, right? And so you can actually have the SQL Server reach out to a remote location, and if it works, great. That means it worked, right? If you see something. Now, that's, hopefully they're going to dive more into that. If not, maybe I'll make a video on it or something. But so now we're going to get into the union-based SQL injection. That's going to do it for this video, guys. I think 30 minutes is the sweet spot for these videos. 30 minutes. I don't want to go more than that because they do get complex, and I want you guys to be able to take them, break them down, and work with them. So next time we're going to, on part 3, we're going to do this, subverting query logic using comments, union clause, union injection, and then the final one we'll do the rest of them to close it out. So actually we'll probably do these, and then we'll probably do the skill assessment at the end by itself, so that way you guys can just watch the skill assessment if you're trying to figure out the skills. So hopefully this helps you guys. Let me know what you guys think, and if you guys like the content, please hit that like button, hit the sub button. Again, it helps me out tremendously. So thank you guys, and have a great day.